Hey everybody, it's Ms. Dupree. In today's lesson, we're going to explore molecules. You've already learned about elements, which are substances or materials that are made of only one type of atom. And you've also learned already about compounds, which are made of more than one type of atom. So what is a molecule? A molecule is made of two or more atoms that are bonded or joined together. A molecule can be as small as two atoms, or it can be as large as thousands of atoms. So, we know that an atom is the smallest unit that you can have and still have matter. Gold, for example, is an element. And if you have one atom of gold, you still have gold. But most substances on Earth are made of more than one atom, and these atoms join together to form molecules. So a molecule is the smallest unit of a substance that still has properties of that substance. So, for example, H2O is water. It is a molecule that is made up of two hydrogen atoms and one oxygen atom. So in a single drop of water, there are more than 1.5 sextillion molecules in that drop. That's a 1.5 followed by 20 zeros. So that's a lot of molecules in one little tiny drop of water. But even if you have only one molecule of water, you still have water. So a molecule is the smallest unit of a substance that still has properties of the substance. So here's our next question. Is a molecule considered an element or a compound? Well, actually, a molecule can be an element or a compound. Remember that a molecule is made of two or more atoms that are joined together. So if you have a molecule that is made of two or more of the same type of atom, then you have a molecule that is an element. So let's use oxygen as an example. Oxygen is an element. One atom of oxygen contains 8 protons and 8 electrons, and it's number 8 on the periodic table. But oxygen is not usually found in nature as one single atom. It's just not stable alone by itself. So usually 2 oxygen atoms, when they come close to each other, they will automatically bond together to make O2, which is the gas that we call oxygen. It's a molecule because there are 2 atoms bonded together, but it's also an element because both of the atoms are the same type of atom. But sometimes 3 oxygen atoms bond together to make O3. O3 is a gas that we call ozone. Now, it's still a molecule because it's made of more than one atom bonded together. And it's still an element because it's made of only oxygen atoms. But O3, which is ozone, is completely different from O2, which is oxygen. It has completely different properties. We need O2, which is oxygen gas, to survive, and you're breathing it in right now. But O3, which is ozone gas, is actually poisonous to people. So in certain conditions, when it's really hot temperatures outside and there is a lot of pollution, like maybe from cars, ozone can actually form on the ground, and it can be really dangerous to people who have asthma or other respiratory conditions. So O2 and O3 are totally different substances, but they are both molecules of oxygen, and they are both elements because they contain only oxygen. A molecule can also be a compound if the molecule is made of 2 or more different types of atoms. So for example, glucose or sugar. It's a molecule that is a compound, and that's because one molecule of glucose is made of 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms, or for a total of 24 atoms to make 1 molecule of glucose. But since there are 3 different types of atoms, since we have carbon atoms and hydrogen atoms and oxygen atoms, a molecule of glucose is considered a compound. Make sense? Okay, the atoms in a molecule are held together by chemical bonds. The atoms they're not physically stuck together. It's not like glue. Instead, they're attracted to each other, kind of like the way that 2 magnets will attract each other. But it's not a magnetic bond. We don't have magnets. It's something called a chemical bond. And a bond between 2 or more atoms will be really, really, really strong. So the atoms in that molecule, they are going to stick together. Think of it like really strong magnets that are stuck together so hard that you can't pull them apart. The bonds between atoms, they can be broken. The atoms can be split back apart, but it takes a lot of energy to do that. So you're going to learn more about how atoms bond together in high school. But for now, just know that certain types of atoms tend to bond with other types of atoms to form very, very, very strong molecules. So one final thing that you need to know is how to read a molecule's formula. And we call this a molecular formula. And a molecular formula tells you how many of each type of atom are in the molecule. So here's an example. NaHCO3 is the formula for a substance called sodium bicarbonate. Now, sodium bicarbonate sounds all sciencey, but it's really just baking soda. The elements found in baking soda are, we have sodium, which is Na, hydrogen, which is H, carbon, which is C, and oxygen, which is O. So we've got 4 different elements found in this molecule. And you'll notice that there is a small number 3 after the O for oxygen. And this small number is called a subscript. And it tells you how many atoms are in, how many of that type of atom, So it tells you that 1 molecule of baking soda has 3 oxygen atoms. You'll notice that the other 3 elements, the sodium, the hydrogen, and the carbon, don't have numbers following them. So if there's no subscript, if there's no number after the element, that just means that there's only 1 atom of that element. So let's count a molecule of baking soda. There is 1 atom of sodium, 1 atom of hydrogen, 1 atom of carbon, and 3 atoms of oxygen. So 1 molecule of sodium bicarbonate has a total of 6 atoms. Let's try 2 more examples. Here we have a molecule of N2, which is nitrogen gas. Nitrogen gas actually makes up 78% of Earth's atmosphere. You're breathing it right now. You're breathing N2. It's a molecule that is an element because it's made of only 1 type of atom, nitrogen. And the subscript 2 after the N tells you that 1 molecule of nitrogen gas contains 2 atoms of nitrogen. Here's another one. C9H8O4 is the formula for acetylsalicylic acid. You probably know it as aspirin, the pill we take for headaches or other pains. It's a molecule that is a compound because it's made of more than 1 type of atom. We have the C for carbon, we have the H for hydrogen, and we have the O for oxygen. So we've got 3 elements. But let's look at the atoms. 1 molecule of aspirin contains 9 carbon atoms, It contains 8 hydrogen atoms. That's a horrible 8. There we go. And it contains 4 oxygen atoms for a total of 21 atoms in one molecule. So we have 3 elements, but we have 21 atoms total in the molecule. Of course, the actual aspirin pill that you take for your headache contains trillions and trillions and trillions and trillions of aspirin molecules, and they're all exactly the same molecule with 21 atoms. So I want you to take a look at the glucose molecule and the aspirin molecule side by side. Notice that they're made of the same 3 elements: carbon, hydrogen, and oxygen. But they have different numbers of these atoms. And remember, in our very first lesson, we learned that compounds can have very different properties than the elements that make them. It's the same with molecules. Different combinations of atoms can make molecules that have very different properties. So even if they're made of the same elements, if there's different numbers of those atoms of those elements, you're going to end up with completely different substances. One of these molecules makes sugar, and the other molecule makes aspirin. Okay, that's it for this lesson. Please check out this review slide and make sure that you understand everything on the slide. If not, write down your questions and we'll discuss them in class. Good job, everybody. See you next time.